So let's start by doing some examples, and we'll also learn a small little theorem in the middle. But let's first remind ourselves of an important fact, which is that if you have a straight line, okay, here's a straight line, and I'm going to consider this to be this my starting direction, and let's say I'm standing right over here, and this is going to be my ending direction. So that means I started from here and I turned all the way and went over here. Then this angle is going to be 180 degrees, right? And another thing that you need to remember, let's say that I'm standing right over here, and then maybe I have a starting, I have a starting direction. So here's my starting direction, and then I sort of also have an ending direction, which is, so let me draw the starting direction with a bit more oomph. So I'm going to have this as my starting direction, and this is where I'm standing. Okay, and now what I'm going to do is I'm going to rotate, and I'm going to come back right over here. So I'm going to rotate, and this red line represents the ending direction. So what that means is that my um, starting direction is here, and my ending direction is also here. So what I did was I actually turned, I didn't just stand here, I turned and went all the way and came over here. So this angle is 360 degrees. Okay. So we should remember these very simple facts that angle on a straight line is 180, angle in a circle is 360. Okay, and that's just the statement that that somebody back a long time ago chose that angles, the total angles in a circle are going to be 360 degrees. They could have chosen 43 degrees for all we care, and then we would have been stuck with that. But they chose 360 degrees. Okay, so now let's see a simple example, and there's a very interesting fact that we will discover. So let's draw two lines. So here's one line, here's another line. This is the point of intersection right over here of these two lines. And just see, we'll discover a very beautiful result. So let me call this angle A, and I'm going to call this angle B, and I'm going to call this angle C. I'm going to call this angle D, right? So now please note that this is the line maybe AB, and this is the line CD. So the line AB is straight. Since AB is a straight line, we know that A plus B must equal to 180 degrees, because that's what we know about angles on a straight line. Similarly, um, we know that CD is a straight line. So since CD is a straight line, we know that C plus B must also equal to 180 degrees, right? So A plus B must equal 180 and C plus B must equal to 180. This is because AB is straight, EB is 180 degrees, CD is a straight line, so it's also 180 degrees. And you use O as your place where you turn, right? So now, if you think about it, you're adding, so here's the idea. So here's 180 degrees. So I'm just going to take this as a length. This whole thing is let me make this a slightly smaller so that it's easier for you to see. So this is A plus B being 180. This is C plus B being equal to 180. So this length is 180. Okay, so this whole length is 180, the white line that I've drawn. But now some portion of it is green. So this part is green, and then you're going to add yellow to it and make it 180. And the yellow stays the same, right? So this is the same, which is yellow that has to be here. So this is the yellow part that has to be the same. So you can clearly see, so you can clearly see that the blue part has to have the same length as the green part, right? Because otherwise you wouldn't be able to get to the same answer. This total length, which was from here to here, was 180, and this is true for this as well. Both of these are equal to 180. Since you're adding the green portion to the yellow portion, or the blue portion to the yellow portion is the same. That means the green and the blue have to be the same. So we have just concluded that A is equal to C, and this is a really nice result, and this is called vertically opposite angles. So these guys are called vertically opposite angles. Okay, and similarly you can argue, I'm not going to argue, that B is equal to D. Okay, so B and D are also vertically opposite angles. So this is a really nice result that that you can use. So now you can basically hopefully do all the problems. So let's do a little example. So let's do an example. So we have this problem and we want to find n and m. Okay, so we know that this is the point where all lines are intersecting. So now let's think about how can we find this the angle. So please first note that we have some straight lines. So let me label them for ease. So let's say we can call these lines AB and maybe CD. So AB and CD are straight lines. We know that, and maybe I'll call this point E and this point O. Then we know the angle DOE is 90 degrees, because this right over here means that the angle is 90 degrees, right? That's the convention that we use. Okay, so now we have to figure out N and M, and let's try to do that. So first of all, since CD is a straight line, we know M plus 50 plus 90 is equal to 180 degrees, and that's because CD is a straight line. So this becomes M plus 140 is equal to 180, and then we can subtract 140 from both sides, and if we subtract 140 from both sides, we're going to get M is equal to 180 minus 140, which is equal to 40 degrees. Excuse me. So M turns out to be equal to 40 degrees. Now please note M and N are vertically opposite angles, which would imply that N is also equal to 40 degrees. And just as a check, so you can say, let me write down what we have found out. N is equal to 40 degrees and M is equal to also 40 degrees. Now note that, just as a check, when we add all the angles, so we add 40 to 90 to 50, we get 180 degrees, which is correct. And for example, when we add 90 to 50 to 40, we also get 180 degrees, which is correct. So we can just check that we haven't made any any silly mistake. And this is the typical kind of question that you that you end up doing. So hopefully this should clarify matters. Thank you.